welcome to Gifted Dance Science and Technology Physics class. I'm NC Joshua, popularly known as Oracle. Today we'll be looking at dispersion of white light. What do we have on the board? We have white light going through a triangular prism, and we can see that on refraction it has released, or it has been split into various colors. White light or light passes through a triangular prism and brought out various color. We call that spectrum of color. A spectrum constitutes of various components of color. Now, what are these color? We have it as red, orange, yellow, green, blue, indigo, and violet. I'll repeat again. Red, orange, yellow, green, blue, indigo, and violet. Now, if you see what is occurring here on white light, we're trying to say that all of this color are in white light. All of this color are in white light. So on dispersion, which is the separation of various components color in a white light, is called dispersion. So all of these colors were in this white light, but after passing through a glass prism, a triangular glass prism, all of this color came out like this. And so this spectrum of color has something very important. Why is it arranged like this? Roy, we can have an acronym to remember this. Roy, go, but invite Victor. Roy, go, but invite Victor. That is a good acronym to remember the order of arrangement of this spectrum of colors. Now, look at this, very important. As we go like this, that is on ROY, Roy, go, but invite Victor. As we go like this, what is increasing? Deviation angle is increasing. What again is increasing? Energy is increasing. And what again is increasing? Frequency is increasing. I reiterate again. As we go in this direction, red, orange, violet, green, blue, indigo, red, orange, yellow, green, blue, indigo, violet. Meaning red has, if you compare red and violet, it means the deviation of violet is more than red. The energy of violet is more than red. And the frequency of violet is more than red, because as we go in this direction, all of these things are increasing. So that leads us to say, note, violet is most deviated because deviation increases in this direction. So violet is most deviated, while red is least deviated. So I'll come again. Red is least deviated. Take note of this. As we go in this direction, violet is increasing. As we go in this direction, there's an increase in deviation. So violet is most deviated, while red is least deviated. What again is increasing in this direction? Energy and frequency. But as we come in this direction, it means wavelength is increasing in this direction. So red, that has the least deviation, this same red has the highest what? Highest wavelength. Has the highest wavelength. Now please, what would I have the least wavelength? It means violet has the least wavelength. Now take note, as we go in this direction, speed and wavelength are increasing. So red has the highest wavelength and the highest speed, while violet has the least wavelength and the least speed. Take note of this, very important. Now that now brings us to types of spectrum. What about types of spectrum? We have the impure and we have the pure. What about the impure? An impure spectrum, remember a spectrum is a constituent of colors. So an impure spectrum is one in which these colors they overlap. When these colors they overlap, we call them an impure spectrum. But when these colors do not overlap, there's a distinct separation between one color and the other. It is called a pure spectrum. Now, how can we get, because when looking at this on the board, it is an impure spectrum because each of these lights these colors are overlapping. We now said how to obtain a pure spectrum. There are some materials that are needed to obtain a pure spectrum. What are they? We have one, a light source, two, a slit, three, two convex lenses or two converging lenses. I'll show you how they are arranged. Four, a triangular prism, then five, a screen. Now let's look at each of them in the diagram here. A light source, look at it, a light source. Number two, a slit, look at the slit here, is the slit. Number three, two converging lenses, one before the prism and one after the prism. Number four, we have a triangular prism, which is this. Then number five, we have a screen, which is this. Now, if you check the last color, you have red up and you have violet down. That means that is a distinct separation between the colors that is a pure a pure spectrum. Now take note, the two converging lenses, one before the triangular prism and the other after the triangular prism. So now what's the next thing we'll be looking at? We'll be looking at cases where we will talk about monochromatic light going through a triangular prism and how it appears. Thank you. A case of a monochromatic light. Now, what is a monochromatic light? A light with one wavelength. So, for instance, you have a yellow light passes through a glass prism and it comes out yellow. In this case, there is no overlapping of colors. Why? Because it's the same light that went through that came out. So, it's a monochromatic light. But in polychromatic light, you have a light like a white light dispersed into various colors, and such colors can overlap. We call them impure spectrum. Then when you want to create an impure spectrum, you have a sequence of materials which we did not quite long to arrange in order to get a pure spectrum. Now look at this spectrum here. There is the first prism and there is the second prism. Now, in this case, light, white light, passes through the first prism and the colors are spread out. Then, on passing it into the second prism, now take a look at this diagram. The first prism and the second prism, they are standing erect. The final colors that will be produced on dispersion will be more widened. Because why? When two prisms are arranged on the same format, what happens to the light? It is more dispersed. There is a wider range of color when two glass prisms are arranged like this. But look at this case where the glass prism is arranged in this format. One in the right way, while the other in the opposite direction. What happens is that the white light is dispersed. What is dispersion? The spreading of white light into various color components. What happens when the prism is not inverted? it recombines the color and produces back the white light. So take note, when two glass prisms are not arranged orderly, what happens is that the white light that was dispersed into various color components recombines to produce back the white light. Thank you. Now let's look at color. What is color? You may want to ask, but there's actually no definition of what is a color. Color is just how we see or describe light. That's color. So we say we see all objects by the color they reflect. We see by reflection. So we see all objects by the color they reflect. So a blue shirt will appear blue. Why? It's because it's reflecting blue. A green leaf will appear green. Why? Because it's reflecting green. Now take note, the whole of this color falls on it. We said this to be Roy. Go, but invite Victor. That was our acronym we used. Red, orange, yellow, green, blue, indigo, violet. So all of these makes up white light. So all of these colors falls on the object. On falling on the object, it will absorb all other and only reflect one color. So that color it reflects is the reason why that object appears in that color. So it means if a shade looks blue, it means that the shade absorbs all other colors. The shade absorbs all other colors, but reflects except blue, which is reflected. So a green leaf will appear green because the leaf absorbs all other color but reflect green. So we see the object or the leaf as green because it is reflecting green. So we see everything by reflection. So what about a white light? White is the reflection of all color. Actually, white isn't a color. Black isn't a color. Why? Because when an object reflects all colors equally, when an object reflects all colors equally, we ought to see is white. But when there is no reflection at all from an object, when light falls on an object and all the colors are absorbed, what happens is that it appears black. So black is the absence of visible light. Black is not a color. So when the colors black men, actually we are not black men because black is not a color. Black is the absence of visible light. Why white is the equal reflection of all colors. That is what produces white, and that is how black comes about. So I will show you some examples soon. We have types of colors. What are the types of colors? We have primary colors, we have secondary colors, and we have complementary colors. What are primary colors? These are colors that cannot be mixed to get them. You cannot mix other components of colors to get them. Those are primary colors. And what are the examples of primary colors? We have red, blue, and green. These are primary colors. What are secondary colors? Secondary colors are colors that are gotten by mixing two primary colors together. So when two primary colors are mixed, it produces a secondary color. Now look at them here. We have blue and green. Remember, blue is a primary color, green is a primary color. So when blue and green is mixed, it produces a secondary color. So the secondary color here is cyan, which look bluish in color, but is cyan and it's also called turquoise. Now we have another one, red plus blue gives us magenta, which looks like purple, but it's magenta. So magenta, cyan, and we have the last one, red plus green. Red plus green equals yellow. So yellow, magenta, and cyan, they are secondary colors. I will talk about complementary colors soon. Now, if you come to this chart, you see secondary colors outside the triangles. What are these colors? Now, if I have yellow here, what is producing yellow? Now remember, Yellow is as a result of red and green. What? So it means red and green. So if I have red here, I have green here. Now, what about magenta? Magenta is as a result of red and blue. So I have red, then here will be my blue. So we have the complete triangle. So it means red and green are primary colors that produces yellow, which is the secondary color. We have green and blue, which are primary colors that produces cyan, which is a secondary color. Then we have blue and red, which are primary colors that produces magenta, which is a secondary colors. Now, when all of these primary colors meet at the center, they produce for us a white light. Also, when all of these secondary colors meet together at the center, they produce to us white light. Now, look at this. It means that, look at this guy. Magenta is meeting with green. Look at it, magenta and green. Look at this again, red and cyan. They are meeting at the center. Look at this, blue and yellow. They are meeting at the center. So now, there are ways in which white light will be produced. First, all primary colors. So if red, green, and blue meet, it will produce white light. Another one again, magenta, cyan, and yellow. If they meet, they will produce white light. Another way again can be a primary color and a secondary color. One primary color plus another secondary color would produce white light. So what are complementary colors? Complementary colors are those colors that when they combine, they will produce white light. That's what we call complementary colors. So red, green, and blue can produce white light. Magenta, yellow, and cyan can produce white light. Also, red and cyan can produce white light. Green and magenta, when mixed, will produce white light. Yellow and blue, when mixed, will produce white light. Now, look at this diagram. This can also be expressed as this. How? Look at this. This center part is A. This A, all circles are found in A. All circles are found in A. Look at green, look at red. Red, A is found in red. Blue, A is found in blue. Green, A is found in green. So if you combine red, green, and blue, this center will be a white light. So I can say A equals white light. A equals white. Now, if A is white, what about this? Look at the next one. B is as a result of combination of red and green. B is a combination of red and green. Now you ask yourself, where is red? This is red. Where is green? This is green. So it means B equals yellow. B equals yellow. Now, what's the next one again? D is as a result of green and blue. D is as a result of green and blue. So where is green? D is green, D is blue. So D is cyan. D is cyan. What about C? C is as a result of red and blue. Where is red? This is red. This is blue. So C is magenta. So that's how all of this is explained. So you look at the ones that have the widest range of the circle. B has a wide range of red and green, so we know what B is. C is more of red and blue, so we know what it is. D is more of green and blue, we know what it is. While A is a collection of the whole of them equals white light. This is what we call addition of colors. Now let's look at some questions that will help us in understanding the topic properly. Number one says, a cyan light shines on a red piece of paper. What would be the appearance of the paper? Now, look at the challenge. We have a light, a cyan light, shining on. Let this be the object. A cyan light shining on. What is the paper we have here? What's the paper we have here? We have here a red paper. So this is red. And what is coming is cyan. Now remember, what are the colors present in cyan? Blue and green makes up cyan. So I come here and I write blue plus green. That's what makes up cyan. Meaning these two colors have no relation with red. So what will happen? Red will absorb them. So they cannot be reflected. And any eyes that will see this object, we see it by the color it will reflect. So now blue and green are not related to red. Red will reflect red. It will absorb all and allow only its own color to pass through. So because there is no red, it will stop the blue and green, meaning these eyes here, what this eye will see has no color, hence it will be black. So a red shirt, if a cyan light is shine on a red shirt, what will the observer see will be black. But let's assume that it is white light. White light. Let's assume it was white light that was shone on a red shirt. Now, you remember, white light has all of this color. White light has all of this color, so it will stop, red will stop all of the colors and only allow red to pass through. It will only allow red to pass through. So the observer will see red. The same thing if white light, if this is a green leaf, a green leaf. If this is a green leaf, if white light is shone on a green leaf, all other components that are present in a white light will be absorbed. The only thing that can pass through is green. Because green will allow green to pass. Red will allow red to pass. Red will not allow blue nor green to pass. So the observer will see green. So for number one question, a cyan light shines on a red shirt. Sorry, a cyan light shines on a red piece of paper. The observer will not see any color, hence it will appear black. Now let's look at question number 2. Now it says a magenta light shines on a yellow shirt. What will be the appearance of the shirt? Now look at it again. This is the shirt. What's the nature of the shirt? Yellow. So this is a yellow shirt. So this is a yellow shirt. And what light was shone on the shirt? It was a magenta. Now the question is now, what are the colors in a magenta light? It is blue and red. So I have blue plus red. That's what a magenta has. Now the question is now, if it's blue and red, will red pass through yellow? We red pass through yellow. What is yellow? Yellow is a combination of red and green. That is yellow. Yellow is a combination of red plus green. That's yellow. Look at it again. Yellow is a combination of red and green. Magenta is a combination of blue and red. So now, what color is here that is in here? Red, blue is not here. So hence, blue cannot pass through. What about green? Is green here? Sorry, blue cannot pass through. What about red? Is red in yellow? Yes. Red is in yellow, so it means of these two colors in a magenta light, blue cannot cross, blue will be absorbed, but red will be permitted to pass. So red is permitted to pass. Why? Because red is present in a yellow shade. Yellow is a combination of red and green. So the observer that is to look will see a yellow shade that a magenta light was shone on, it will see it as a red color. So it will be red because it will reflect red. Remember, we see objects by the color they reflect. Now let's see example 3. Example 3 says a red shade when viewed in a pure green light appears dash. So let's follow the same way we do it. Now, what will be here? A red shirt. So this is red shirt. Red shirt. What color came? A green light. So we have a green light. Now, what makes up a green light? Green is just green. There is no other component in a green light. It's just green. So a green light has no correlation with red. Red is just red, green is just green. Some textbook will say it will appear as magenta. No, you are not missing the colors. We are trying to say red cannot permit green to pass through. Red will absorb green. So the observer will not see any color. What will the observer now see? It will be just black. So a green light shone on a red shirt will appear black to the observer. Why? Because green cannot pass through red. So it will not reflect red. Instead, it will be stopped by red and the observer will see black. Thank you. Now, let's look at example 4. Example 4 says, a green, white, green flag will appear dash when viewed through a yellow light. Now, what we'll do here is that if you check this green, white, green, it's just two colors that are available here, not three. So whatever we do for the green, the first green is what the second green will still take. So we have just two colors here, a green and white. So a green, white, green flag, when viewed with a yellow, through a yellow light, will appear that. So first, let's take the green. Let's take the green first. Now, this is green. Green. So now we are viewing through yellow. Yellow is what is coming. So yellow is coming to green. Now, what is the component of yellow? Is red and green. So if yellow is red plus green, now look at this. It means that yellow being red plus green and yellow having green, it means that red will be absorbed and green will pass through. So for a yellow light, please take note again, yellow is a constituent of red and green. And green is the shade or is the flag we are taking first. So I'm not saying that this red will be absorbed while green will pass through. So it will appear first as green to the observer. It will appear as green. Now, it means that I have whatsoever happens to the first green happens to the second green. Now, I now have the second one, which is white. Now, remember, it's a green, white, green. So, whatever happens to this first green is what will appear to the second green again. So, what about for white? Now, what is coming is a yellow light. A yellow light. A yellow light is coming also. Now, yellow is a combination of red plus green. Now, because it is a white light, as yellow comes, remember, because it's a white shade, as yellow comes, it will give out everything that yellow gave to itself. So, yellow will permit, remember this white, yellow will permit red to go through and also permit green to go through. White will not hold any of these components because all colors, the reflection of all colors equally is what we call white. So any of these components will not be heard. So the observer will still see yellow. The observer will still see yellow. Why? Because if you give yellow to white, it will appear as white. If you give yellow to white, it will appear as yellow. If you give red to white, it will appear as red. If you give green to white, it will appear as green. It will not hold any of the components. Why? Because all of these components are in white. White is a collection of all of these components. So the man or the observer will still see yellow. Hence, what will the observer now see? If a green, white, green flag is viewed through yellow light, it means it will be what now? Green, yellow, and green. That's how it will reflect. Thank you.